like I said, just try your best. So the first type of equation we're going to be looking at is if you have like a log equals a log equation. Pretty simple, but some of these problems you might have to kind of use what we learned about condensing. You want to make sure you have one log on both sides of your equations. It's really important. So if you have multiple logs, you might need to kind of condense them together so you get it in this form. But basically, the nice thing, it's similar when we have like a common base on both sides. But basically, if you have log base 5 of something equals log base 5 of something, keep in mind it's really important these are the same. Basically, if you have this situation, you can just get rid of your logarithms. And then just kind of solve your equation for why this works. I mean, if you think about it, if you take this 5 up to this side or 5 equal to this side, basically it's similar to like when you had a common base. Like if you had something like this, remember, you could just get rid of your 5s and set the exponents equal to each other. It's really the same thing that's going on here. So if you solve this, you could just subtract the 5x. You get 9 equals x. So not too bad. Similar idea in this next one. Like I said, it is really important though that you have the same base. Like if you had different bases, you can't necessarily do this, or you might have to do more in your problem to kind of make them have the same base. I don't know if we'll see anything really that involved, but like it is really important you have the same base with these. So like I said, since you just have one log on both sides, just kind of simplify them. Or just get rid of your log, sorry, and set what you have inside your functions equal to each other. And then just solve your equation, depending on how complicated what you have on the inside. You could have very simple, like a one-step equation, all up to maybe like a quadratic or even something more in depth. It kind of depends what they're throwing, but usually you're not going to see anything too crazy. But like in this, you want to get all your n's. So I'm going to move all my n's to my right side. I'm going to move all my constants or to the left side. So I would get 6n equals negative 42. If I divide, I would get negative 7 equals n. And there, you could solve it slightly different steps, but so similar idea. I'm going to skip some of these problems because I think there's a little bit of redundancy, or maybe if you want to try number 3, basically nothing too crazy going on here. But I'm going to just jump into number 4. So like I said, though, if it's not in the form where you have like a log to equal a log. Oh, and one thing I should say, we should also be checking for extraneous solutions. Like for this first one, for example, if you plugged in 9 into this, you would get 54. If you plug 9 into here, you would also get 54. So this does work. You do need to be careful. You can also get extraneous solutions when you're looking at these. If you plug negative 7 into this, that would be 1 plus 28. That would be 29. So this would be negative 14. These so far these have worked though. If you plug them in, you get the same thing in both, like inside these functions. But you do need to be careful. You can get extraneous solutions if you're not looking out for them. Just kind of like when we did our radical equations. So for this one though, you want to make sure you just have one log on both sides. We need to combine these two logarithms. So remember, if you have addition, that's really the multiplication property. So you could really just multiply the 4 times the y plus 5. You'd have to distribute. So you'd really have 4y plus 20. But then you could get rid of your logs and just solve this equation. Subtract the 20. You would get 4y equals 52. Divide by 4, you would get 13. Then you just want to kind of double check if you plug it back in, do you get the same thing? Like, and you could plug it in, like once you get to this spot, like if you plug 13 in for that y, do you get 72? 4 times 13 is 52 plus 20 would be 72. So far these are all working. I want to pull up the key. I want to see it. Do any of these really have extraneous solutions? Oh, here, let me show you. Actually, the one I skipped, number 3, you actually get an extraneous solution. So let me actually do number 3. So sorry, I'm jumping around a little bit, but like this one, if you solve, if you add the W, did I do that right? Oh, yeah. You would just get 6 is your answer. But here's the deal: if you plug this back in, you're going to get -12, and you're going to get -12. The one thing is, with logarithms, though, is you can never have a negative answer. So if you plug it back in and you get a negative answer, like if you plug 6 into here, you're going to get -12. If you plug it, even though they're the same, you can't have a negative logarithm. We'll talk about why. So this one would actually be no solution. You can't have a negative log. And let's think about why that's true. Like, for example, if you had, let's just say you had log base 10 of -3 equals something. It doesn't even matter what it equals, but is there is there any way you could take 10 up to a power that's going to give you a negative number? No. Like, remember, if you have a negative exponent, it just flips it into a fraction. If you have a positive number, like for example, 10 up to the -3 is 1/10 to the third. Like, there's no way you can have the base up to a number that's going to give you a negative number. So I guess really all you're going to be on the lookout in terms of extraneous solutions, as long as you plug it in, as long as you don't get a negative answer, you're good. You could have 0, like you can have logarithm of 0. That's so. Wait, actually, you can't even have 0 because nothing up to a power is ever going to give you 0 as well. So as long as you don't get a 0 or a negative number when you plug it in, you're good. So for example, when I plug 9 into here, I get a positive. I get a positive. When I plug -7 into here, I get positive answers. That's all good. And they should be the same, but honestly, that's never really going to be an issue. Like, you shouldn't ever not get the same thing. Like, I can't really think of a way that would happen from what we're doing. But really what you're going to be on the lookout for is when you plug it in, do you get positive answers? If you get a negative, then you just can cross it out. That's not a true solution because you can't have a negative number plugged into a log. Like in your calculator, if you have like a log button, if you type log of -5, it's going to give you domain error or a value. I don't know how well you can see this, but I don't know how well you can see this. But if I type in log of -5, for example, going to tell you domain error. It might say like a different error message, but you're going to get an error because there's no way you can take, it doesn't matter what your base is, whatever your base, if you have a base up to a power, there's no way you can equal a negative number. And you also couldn't have 0. So I guess if you got 0, that would also be a problem because you can't raise any exponent's never going to give you 0 as well. So I hope I'm not throwing you too much off with these extraneous, but sorry, I should have maybe said it better from the start. But basically, you can't have a negative input into a log function. So if that ever happens, that is going to actually not be a solution. So it'd be like no solutions. So I shouldn't skip 3 actually. That's a good one. 5, like I said, you kind of want to simplify your log expressions. Remember, if you have a 3 in front, you can really raise, that's your power. So that would really be log base 7 of 4 to the 3rd power, or 4 to the 3rd power that'd be 4, 16, 64. So if you want to just write that as a 64, I guess. Then you could basically get rid of your logs, then solve this basic equation because you have the same base on both sides. And then just solve what you got. So add the 8. That would be 72. Divide by 4, you would get 18. And if you just plug this in, it really doesn't matter too much, to be honest. Like, if you plug it in, you're going to get 64. But you just want to make sure when you plug it, that like you just want to double check if you plugged it back in, would you get a negative result or zero? Like you don't like if you get zero or a negative number, that's not a true solution because you'd get undefined. Like you can't have a negative number inside your logarithm. So like if a negative number that means you have no solutions or it's like undefined. So remember, nothing like whatever your base doesn't even matter what your base is, but nothing you raise your base up to is ever going to give you a negative or zero. So if you guys want to try, maybe like I know some of these are getting a little crazy, but see if you can try like a question like 6, 7, and 8. Like, I mean, the first thing you want to do on 6 is see if you can condense this into a single log and then set them equal to each other. And just double check when you get your answer, just plug it back in just to make sure you don't get a negative solution. It's not going to come up a ton, but it is possible if you're not careful. Like, I mean, honestly, it's probably not something you have to be too on the lookout for unless they're kind of trying to throw you down that path. But you can get technically you can get extraneous solutions based on that. But I don't think it's a matter of plugging it in to see if they equal the same. I mean, they always should be. I don't think that would ever really be an issue unless you solved it incorrectly. I think it's really just you're more looking out just to make sure that you get a positive result when you plug it back in. But let me know too if anyone, if you're having trouble. I'm gonna pause the video, start recording. But the first thing you want to do is combine these two logarithms. Remember, if there's a minus sign between these, you can use the quotient property. So that means you're going to divide like your inputs into the log. So 68 divided by 4, like it'd really be this. I mean, I'm going to erase this in a second just for space. Remember, you could combine those like that. But 68 divided by 4 would be 17. So then from here, you can just get rid of your logs because you have one log and then the same logs on both sides. So 17 equals 3n plus 11. So subtract the 11, you would just get 6. Then divide by 3, you would get n equals 2. And if you plug this in, like I said, really all you're on the lookout, you just want to make sure if you plug this in, will you get any negatives? Well, if you plug 2 in for here, you're going to get a positive. So this is a good solution. Like you just want to make sure if you plug that back in, are you going to get a negative or 0? I keep just saying negatives, but remember you also couldn't get 0. So if you plugged it in and you got 0, that would also be a problem. But that works just fine. For number 7, you want to kind of just deal with this number in front. Remember, you could take that as a power, like so the 25 up to the 1/2. Remember, really the 1/2 power, remember, is just a square root. So that would just be log base 6 of 5. That's sloppy. And then, I mean, there's nothing you really need to do on the right side. So then you can get rid of your logs. 5 equals that 23 minus 4w. Subtract the 23 over, you would get negative 18. Right? Did I do that right? Just making sure I don't screw up the pencil math. Yeah, negative 18 equals negative 4w. You are going to get a fraction for this one. So 18 divided by 4 would be 4.5, or if you want to keep it like it'd be 9/2, or I'll just put the decimal, which is okay. You can get decimals, no big deal. You just want to double check if you plug that back in, would you get a negative answer? Well, 4.5 times 4, well, that would be 18. So 23 minus 18, that's all good. You get positive 5, I mean, which is what you should get. But like I said, we're really only worried if we get negative results. That's really the only thing you're going to really be worried about. Similar idea with number 8. I mean, there's nothing you have to do on the left side, but this one you could first take the 2 up to be a power. So this would really be log base 3 of 36 minus this log base 3 of 4. Remember, you can then divide those. So like basically you would have on the right side log base 3 of 9. So if you get rid of your logarithms, you'd have 2p minus 5 equals 9. So then if you solve that, add the 5, that would be 14. Divide by 2, you would get 7. If you just double check, like I said, if you plug that back in, you're going to get a positive result. So all good. I mean, you could work it out to see that it's the same, but really that's the only thing you really need to be worried about. So just kind of be on the lookout. Like I said, it doesn't really come up a ton. I mean, honestly, when I think of log equations, I kind of forget. Extraneous solutions didn't come into my mind right away because it doesn't happen a ton. The reason it happened in number 3 is because from the beginning it had a negative on the inside of your logarithm. So if your solution's positive, that's a big no-no. So that's kind of the issue with that one. But most of these problems, you're really not seeing anything like that. I'm going to skip just because we're a little bit on a time crunch. I want to skip number 9 and 10. Nothing too crazy going on here. I mean, you would get some quadratics. Let me just double check the key just to make sure. I don't think anything crazy happens though. Doesn't look like it. I mean, you will get quadratics, so you will get like 2 answers, but nothing really crazy happens. I'll make sure when I put up the key that those are worked out. But the second type of equation we're going to be looking at is basically if you have log on one side of your equation equals a single number on the right side. We kind of saw this a little bit in some of the delta math. Some of you, depending on what questions they asked, you would have kind of seen this. But basically, if you switch this into exponential form, remember you take your base. So 2 up to the power, like that's your power on the other side. So 2 to the 6th power equals what we have inputted into our logarithm. So, I mean, and then just kind of use a calculator to help you out or count it on your fingers. But 2 up to the 6 would be 64. And then, I mean, just to solve this, you would get 68. You add that 4 over. And if you plug that in, I mean, 68 minus 4 is a positive, so you're all good. So similar idea, like I said, you just want to make sure if you have extra junk on this side, like the 7, you'd want to add it to the other side before you start changing it into exponential form. You want to make sure basically you have your log of whatever equals your number. You don't want like extra stuff added, or you don't want a coefficient in front of your log either. You'd want to divide that over before you mess with it. But we would have 3 up to the 4th power equals 4x. So we can just kind of 3 to the 4th power, either plug that in a calculator or just work it out like 3 times 3 times 3 times 3. That would be 9, 27, 81. Just make sure my math's not wrong there. 3 to the 4th. Yep, that is 81. So, I mean, your answer is going to be a fraction, which no big deal. Or you could get the decimal if you prefer, which is, that's 20.25 if you prefer to write a decimal. But if you plug that in, I mean, there's no way you're going to get a negative, so it's all good. If you have multiple logs on one side, you want to condense, similar to what we saw in the front. So you're going to kind of want to use what we learned about condensing before break, which hopefully is coming back a little bit. I know it's been a bit. I hope we were doing okay before break, but I know if it was, hopefully it's starting to come back. But basically, remember, you could combine these. Remember, addition, you can multiply. Just be careful. You'd have to distribute or multiply both parts by the 2x. So that'd be 2x squared minus 10x. So you'd have, remember, log by itself, remember, that's a base of 10. So 10 squared equals 2x squared minus 10x. So that's 100. I did not give myself enough space. I wrote way too big. Since this is a quadratic, remember, you're going to want to get everything on the same side. Usually I just try and keep my x squared part positive if possible. So if I subtract the 100 over, you basically have this. Minus 100 equals 0. I'm kind of switching the sides too. But if you subtract the 100 to the other side. So then this, you could factor out a GCF, like a 2. And you just want to see, does this factor out nicely? Because if not, you might have, like worst case, you'd have to do like quadratic formula or something like that. But I think this factors out nicely. What multiplies to negative 50 adds up to negative 5? Well, oh, that would be minus 10 plus 5. So my two answers, sorry, and I know I wrote way too, I'm just going to cross out 14 for now because I'm not doing it. I wrote way too big, but you would get 10 and negative 5. You just want to double check, especially when you get multiple solutions. If I plug this back in, would I ever get a negative, like when I plug it inside of these parentheses, do I ever get a negative? If I plug in positive 10, that's all good. That would be 20, that would be 5. But the problem with negative 5, if I plug negative 5 in, I'm going to get a negative result. Like 2 times negative 5 is negative 10. And also negative 5 minus 5 is negative 10. It doesn't matter that they're the same. The problem with this solution is you can't have a negative input into a log. Because like I said, like if you, let's say you did have a negative number, like let's say our base was 10. No power of 10 is ever going to give you a negative answer. Like 10 up to positive 2, you're going to get bigger and bigger. If you do 0, you get 1. If you plug in negative 5 in for that x, you're going to get a fraction, but it's still going to be positive. Like there's nothing you could plug in for like an exponent that's ever going to give you a negative solution. So that's why it's a problem. So we would only have one solution for number 13. So how are we doing on time? Can do maybe a couple more. Let me look. Sorry, I know I'm running really, really big. I'll make sure I upload like a key with all of these worked out. I'm going to skip 14 just because of the space issue. I'm going to do number 15. Maybe we'll kind of call it a day. So we want to combine or condense our logarithms. So remember, a plus sign, you can multiply these together. So if you like kind of distribute that x, you'd have x squared plus 9x. Just forgot my base. So we really have 6 squared equals this x squared plus 9x. That's really 36. So you kind of want to move everything to the same side. Because remember, when you're solving quadratics, you always want them to equal 0 if possible. So if you subtract that 36, you basically have this, which this does. Does this factor out nicely? What multiplies to 36 and adds up to 9? You could do 12 and 3. So the plus 12 minus 3. You get negative 12. And you'd get positive 3. So just to kind of double check, like I said, you want to just make sure if you plug it into either of these logarithms, are you ever going to get a negative result? This negative 12 is a problem. If you plug negative 12, you're going to get negative 3 in the first one. And obviously in the x function, it would just be negative. So that's a no-go. But 3 is all good. So like I said, you just want to double check if you plug it in, are you going to get a positive result? If you get a negative result or 0 when you plug it back into the logs, that's not okay. So that's it for today. There is no assignment. I'll start working on it. I might post it earlier. I think tomorrow I'm just going to show you a couple other types of problems, and then I'm going to make kind of like maybe a bigger kind of delta math section, and I'll post that hopefully at least definitely by Wednesday. So if you want to start it on Wednesday, but then I'll give you some time in class probably Thursday. So tomorrow I think we'll just maybe look at some more, but I'll try and get the assignment maybe posted early. So even if you want to start like on the parts I've taught you, maybe you could start looking at that tonight. I'll start making up the delta math. So that's all I have for today. I'm going to end a little bit early.